Today we're going to look at solving applications of primary trig ratios. So we're looking at real life problems, and specifically we're going to be looking at using what we call the angles of elevation and the angles of depression in order to solve those things. So when we talk about angles in the real world, we always need a frame of reference, some place that we can use as our starting point. And generally it happens to be where someone is standing and looking relative to another object. So we're going to look at two key things. One is called an angle of elevation. And when you have an angle of elevation, it means that you're looking up at an object. So when you're looking up at an object, you are standing at the base and you're looking up at that particular object. So in this case, let's say you have, I don't know, human being who's just standing there. There's my happy little human being. He or she is looking up at a particular object. So the frame of reference is this angle here in red. Okay. The other frame of reference that you could have is someone looking down at an angle. Okay, so this is common if you have a question like someone is standing on top of a cliff looking down. Okay, and in this instance, we actually have a person standing up there. Okay, let's say they're standing on top of a cliff. Okay, and they're looking out horizontally down at a particular object. And so the angle that they're looking down is actually from the horizontal, and that's the key thing. That's the thing that people get most confused by, is that they're looking down from the horizontal. Okay, so from a straight line they're looking down. So it's the angle between the horizontal and the downward thing. So you basically have an upside down triangle when you're looking at an angle of depression. Okay, and so we can use what we've already learned in terms of using primary trig ratios to solve for an unknown side length or to solve for an unknown angle in any number of these real-world problems. So let's take a look at example number 1. Okay, so it says that you're standing 11.2 meters from the wall of the school. Okay, the angle of elevation from where you are standing to the top of the school is 37 degrees. Find the height of the school. So as a word problem, we need to figure out, okay, what does a diagram look like? Because a diagram is a great way of communicating your understanding of the situation. So let's say that you're standing right here, okay, and that dot represents you. Okay, if you're standing 11.2 meters from the wall, we can assume that the ground is flat. So let's assume that we're standing 11.2 meters from the wall. Okay, the angle of elevation from where you're standing to the top of the school is 37 degrees. So you're looking at the top of the school. So let's assume the top of the school is here. So this vertical line represents the top of the school. Okay, and from where you're standing in this position, because this is you, okay, to the top of the school, that's going to be that angle there. That's 37 degrees. Okay, so because that angle is 37 degrees, we want to figure out the height of the school. So we're actually trying to figure out that value right there. Now, between the ground and the school, it's important to know that that is actually going to make a 90-degree angle. Okay, so now we actually have a diagram that we can work with. So we know that we're standing 11.2 meters away from the school. The school is a certain height. Okay, and your angle of elevation to the school is 37 degrees. Okay, and we want to figure out, well, what's the height of the school? So in this instance, we need to, again, as we always do, label our triangle, because now we have a triangle. We've made the diagram. So if we label this triangle, we got to figure out our HOA. So that's our hypotenuse. Our opposite side length is the side across from the angle in question. So in this case, this is our, sorry, not the adjacent, that's our opposite side. Okay, and then our adjacent side must be the remaining piece. So our adjacent side is down there. So now we got to figure out, okay, what primary trig ratio should we use? Okay, because it's a right angle triangle. Can't use Pythagorean theorem because we only have one side length, but we have an angle, so it's got to be a primary trig ratio. So let's go through and solve that. We've got ka or TOA? Okay, and we want to decide which one of those three things should we use. Well, we're trying to figure out the value of x, and we know that x represents the opposite side length. So I'm going to underline the O's, because that's what I'm looking for. I'm looking for the opposite side length. So based on that, I know right off the bat that I can't use the cosine law, okay, because the cosine law is not going to allow me to solve for the length of the opposite side. So I'm going to cross that piece out. So what piece of information do I have? Well, I know that the angle of elevation is 37 degrees. So I can put a check mark above the angle. The other piece of information that I have is I know what my adjacent is. Okay? And because I know what my adjacent is, by process of elimination, I have to use the tan function because only the tan function has enough information for me to be able to solve this particular problem. So I'm going to use tan of x is equal to the opposite divided by the adjacent. So now I'm going to substitute in my values. So I know that my angle is 37 degrees. We determined that earlier. So 37 degrees. My opposite is what I'm looking for, and we can call that x. And my adjacent value is 11.7. Okay, so 11.2 meters. Okay, so now I've got enough information to solve. Now, as we looked at back when we talked about how to solve for side lengths, we know that any number can be written as a fraction. We have a fraction on the right-hand side of the equal sign, so we got to make a fraction on the left-hand side of the equal sign. So tan 37 is the same thing as tan 37 over 1. Okay, and so what we can do now is we can use our cross-multiplying skills to isolate x and solve. So in this case, we're going to figure out what x is. It's by cross-multiplying. So I end up with x is equal to 11.2 times tan of 37 degrees. Okay, and so if I put this into my calculator, I can solve this by putting in 11.2 times the tan of 37 degrees is equal to approximately 8.4. Okay, so the height of the school is approximately 8.4 meters. We can take a second example. Okay, and the second example that we have here is also an angle of elevation question. It tells us that right there. Okay, so in this case, it says that a truck is traveling 6 kilometers up a mountain road. The change in elevation is 0.375 kilometers, same unit, very helpful. What is the measure of the angle of elevation? So now we're trying to figure out an unknown angle. Okay, so we don't know what this angle is. Your angle of elevation as the truck is moving up, okay, we don't know what that angle happens to be. So, as we always do, we're going to start off by labeling this triangle. So this triangle, we've got our h value. We want to figure out opposite value. And therefore, the third side has to be the adjacent. Okay, so we've labeled our HOA. So we know that as the truck is driving up the hill, it's moving 6 kilometers up, and it's moving at an angle of elevation. Okay, so I would draw a truck, but that would frankly just embarrass me. So we want to figure out which ratio do we need to solve with. So again, we're going to go through, write out our SOHCAHTOA. Okay, so what are we looking for? Well, we're trying to figure out the angle. And because we don't know the angle, we're actually going to underline all three. Okay, because we don't know the angle, it could be any one of them. Okay, potentially. So now we want to figure out, well, what information do we already have? So we know that we have the hypotenuse, which is 6 kilometers. And we also know that we have the height of the opposite side. Okay, so based on the information provided, only the sine ratio has enough information to answer this particular question. So we're going to go through and we're going to solve for the unknown angle. And we'll call the unknown angle x, because we don't know what that is. So we know that sine of x is equal to the opposite divided by the hypotenuse. So what I'm going to do is I'm going to substitute in the values that I know. I know that sine of x is equal to my opposite, which is 0.375 divided by 6. I'm going to simplify that fraction, okay, because we can. We have both the top and the bottom numbers, so let's simplify this. 0.375 divided by 6 is going to be equal to 0.0625. Okay, and so now we have to figure out what x is. And right now, we've got sine of x, but we need to get sine all by itself. So in order to get sine all by itself, we have to do the opposite operation of sine. So the opposite operation of sine is sine inverse. And we've got sine x is equal to, and again, if we did sine inverse on the left, we have to do sine inverse on the right. 0.0625. Okay. And so this is going to mean that x is going to equal, because again, sine inverse and sine cancel each other out. So if I want to figure out what sine inverse 0.0625 is, plug that into my calculator, and I get approximately an angle of about 3.6 degrees. Okay, so my angle of elevation is approximately 3.6 degrees.